For the fast solution, watch the first 30 seconds detailing the problem and then skip to 7:53. Hello everyone, this is a physics problem involving change in speed, difficulty medium. You are driving on the freeway and notice that it takes time t1 to go exactly 1 kilometer. You increase your speed by 3 meters per second and notice that the time to travel another kilometer is decreased by 6.5 seconds. What was your original speed? So we're going to have two equations, 4 variables. As you can see, this is the way I write my equations. Yours may differ. Anyways, we have V1, which is your original speed, delta T1, which is the time it takes you to complete the first kilometer. Then we have V2, which is your speed after the increase, and delta T2, which is the time it takes for you to complete the second kilometer after your increase in speed. As you can see, the 4 variables are written. There's obviously going to be more than one way to solve this problem. I am just going to take you through one way. If you have any questions, you can ask me in the comment section. Okay, so we have the first equation and the second equation. The question asks, what was your original speed? We are going to solve these equations using the substitution method. Therefore, we're going to rewrite them, and we want to make sure that we solve for time. So our first equation will be delta T1 equal to 1 kilometer over V1. That one's easy. Our second equation is delta T2 equal to 1 kilometer over V2. Now, from our previous equations, we see that delta T2 is equal to delta T1 minus 6.5 seconds. So we're going to rewrite that for delta T2 and insert it into this equation, which we are left with that one. Then we're going to solve this for delta T1. We're going to add 6.5 seconds to each side, and we're going to have delta T1 equal to 1 kilometer over V2 plus 6.5 seconds. Now we're going to take out V2 and write it in terms of V1. So we have this equation, okay? The next step we're going to do is we're going to set equation 1 equal to equation 2, which gives us this. The next thing we're going to do is we're going to multiply both sides of the equation by the same thing, which is V1 times V1 plus 3 meters per second. Okay. Rewritten, we're going to get this mess. Alright, so I wrote it out the long way so that way you can follow me step by step. Okay, so this is equation 1, this is equation 2. This is what we're multiplying both sides by. Okay, so through cancellation, we know that V1 and V1 are going to cancel. That leaves us with 1 kilometer distributed to V1 plus 3. So we have 1 kilometer V1 and we have 1 kilometer 3 meters per second. Okay, now we're going to go to the other side, and here we have 1 kilometer over V1 plus 3 meters per second is going to get multiplied into this. Through multiplication by fractions, these two will cancel each other out. That's going to leave us with 1 kilometer times V1. Now we have 6.5 seconds, and it's going to get multiplied into this. Okay, so that means 6.5 seconds times V1 squared, and 6.5 seconds times 3 meters V1, which we have here. Now what's going to happen is we're going to see that as we solve this equation, we're going to get rid of this, and we're going to get rid of that. Okay, that means we're going to be left with 6.5 seconds v1 squared plus 6.5 seconds times 3 meters per second v1, and then we're going to take this minus, right, because we're going to minus both sides, minus 1 kilometer 3 meters per second. Okay, this is going to be equal to 0. You should notice that we have a quadratic equation. We have v1 squared, we have v1 to the power of 1, and then we have two numbers over here. Another thing that you might want to do is check to see if it is dimensionally consistent. You can look at my other video to figure out how to do that if you need to. I'm not going to take the time to do that right now. Punching this into a calculator, we have 6.5 for A. We have 6.5 times 3 for B. And we have negative 3,000. Okay, because remember, 1 kilometer is 1,000 meters. Solving this gives us 20.0. So it says, what was your original speed? Our original speed was 20 meters per second. This is our guess. Now we're going to check to see if it works. So we're going to go back to our calculator here. We are going to do 1,000 meters divided by 20 meters per second. That's 50 seconds. Now we're going to do 1,000 meters divided by 23 meters per second, right? So our original speed is 20, then we increase by 3 meters per second, and our time to travel is decreased by 6.5 seconds. This should give us 43.5. It gives us 43.47. Rounded to 3 figures is 43.5. Okay, so therefore we know that our original speed was 20. Our speed after the increase was 23 meters per second. For those of you that just want to see maybe another way how to solve this, this is how I solve them. It's a little bit faster. What I do is I write my original two equations, and I will substitute variables for the variables. So I use A for V, I use B for T. I don't put the subscripts, I know what they are. I don't label the units. This is done strictly for speed. There are some errors involved sometimes, but not too much as long as you write down what you're doing. So the first equation solving for B is C over A. Second equation solving for B, there you go. There's that part. Then you set B equal to B. So then we have C over A equal to C over A plus D plus F. Then we multiply by A times A plus D, which gives you that. Then we cancel out CA equal to 0. We have a quadratic equation. We're left with this. We substitute back in the 6.5 for F, the 3.0 for D, and CD, which is 3 times 1 kilometer. Put that into the calculator. We just did that a minute and a half ago, and you get the same answer. So yeah, leave a comment, ask a question. Thank you.